So again, good afternoon to everyone. And for our session for this week, we are just to continue with statistics, learning about t-test, chi-square, p-value, and more. So please take note. Last time, I already posted the things we've discussed last time, the presentation on market research tools and customers' needs, data. So for now, we'll have some more statistics about t-tests. Kasi last time we talked about, I guess, more on ano siya, tawag doon, regression, no? Or yun nga, regression. Okay, so I guess we can start now so that we will also be finished earlier.
Instead of bombarding you with complicated formulae and statistical theory, I'm going to walk you through a way of thinking, and that's going to enable you to address the most common statistical questions. When we look at sample data, for the most part we see two things. We see differences between groups, so men are taller than women, and we see relationships between variables like taller people weigh more than shorter people. And the big question is, are those differences and are those associations or relationships real? And I'm going to talk you through what it is that we mean by the term real. Over the next few minutes, we're going to take a look at a very simple data set, and we're going to see how, by looking at various combinations of variables and variable types, we can identify very specific differences between groups and very specific relationships between variables. And I'm going to walk you through when and how to use statistical tests and how to interpret your results. Now let's imagine that we have a research question and it's about the height and the weight of people living in Ireland. Of course, we can't measure the height and the weight of the entire population. So instead, we take a random sample of the population and we measure the weight and the height of that sample. And we collect some additional information like gender and age group from each of the people in our sample. And we arrange these data in a spreadsheet or a data set with the various attributes in columns. And these are called variables. And these variables will be the object of our inquiry. Now, most data sets that you work with will contain two types of variables, categorical and numeric variables. Variables like gender contain categories, as the name suggests. Think of them as groups or buckets that the data can be arranged into, in this case males and females. Numeric variables like height are numbers, as the name suggests, and can be arranged on a. Now, most data sets that you work with will contain two types of variables, categorical and numeric variables. Categorical variables like gender contain categories, as the name suggests. Think of them as groups or buckets that the data can be arranged into, in this case males and females. Numeric variables like height are numbers, as the name suggests, and can be arranged on a number line. Now, to better understand our data and to make sense of it, we summarize it and we visualize it. In the case of categorical data, we can count up the number of observations in any given category and we can represent them in a table and on a bar chart. And to summarize numeric data, we're firstly interested in the spread or the distribution of the data. So we might describe the range of the data, the interquartile range. We could also include the standard deviation. To get a sense of the middle of the data, we use the median, which divides the data into two equal halves, and we use the mean, which is the average. The mean is probably the most commonly used summary value to represent this kind of data. We can visualize our data using a plot, which is a visual representation of the range, the interquartile range, and the median. And of course, we can create a histogram, and this gives us the shape of the data. So I hope you can see that this process of summarizing and visualizing the data, we can visualize our data using a box plot, which is a visual representation of the range, and we use the mean, which is the average. The mean is probably the most commonly used summary value to represent this kind of data. We can visualize our data using a box plot, which is a visual representation of the range, the interquartile range, and the median. And of course, we can create a histogram, and this gives us the shape of the data. So I hope you can see that this process of summarizing and visualizing the data takes it from being just numbers and words on a spreadsheet and turns it into something that is meaningful to us, something that we can get our heads around, something that we can think about. Now, in this very simple data set, we've got two categorical and two numeric variables. And things start to get interesting when we start looking at combinations of variables. So, for example, we can take a look at a categorical and a numeric variable like gender and height. And so we can group the data by gender, which is the categorical variable, and create a summary of the numeric variable, in this case height, that is separated out into those two groups. And looking at the summary, we can see that in our sample data, men are on average taller than women. What I want you to see here is that we've looked at a combination of a categorical and a numeric variable. But as you can imagine, there are other possible combinations of variables that we could have looked at. We could have looked at height and weight, which are both numeric. We could have looked at gender and age group, both categorical. And in each case, we might see either differences between groups or relationships between variables. And in each of these cases, there are specific statistical tests that we can apply to see if what we are seeing in the sample data has implications for what we think about the wider population. Can we infer anything? Is what we are seeing statistically significant? So let's take a quick look at the 5 most important combinations of data that we have. And we'll look at firstly, what might we observe in our sample data given that sort of combination of data types? And secondly, what statistical test we might apply to determine whether or not we can infer anything about the wider population. So we might look at a single categorical variable like gender, and we could do a one sample proportion test. For 2 categorical variables, we would do a chi-squared test. For a single numeric variable, we'd do a t-test. If we have a categorical and a numeric variable, we do a t-test, or analysis of variance, or ANOVA, if there are more than 2 categories in our categorical variable. And for 2 numeric variables, we do a correlation test. Now, I'm going to come back to each of these scenarios and each of these tests, so don't panic. At this point, what I want you to see is how the data can be divided up. And in just a few minutes, we're going to take each of these scenarios and work through exactly what questions you can ask and how it is that you can apply statistical tests, and importantly, how to interpret your results.
What will you do for the first time this Christmas? Will you reunite with your loved ones? Will you go out into the world?
Now, before we carry on, I just want to say a big thank you to Biomed Central, or BMC, for sponsoring this video. BMC are a publishing company that publish open access journals, and that means that the full text of all of the papers published are available for free to anyone in the world. I'm the editor-in-chief of one of the journals that they publish called Globalization and Health. I'm genuinely impressed with them as a company. I believe that they have integrity, and I honestly believe that they are making the world a better place. They have a portfolio of over 300 journals that they publish, so check them out at biomedcentral.com. I'll put a link in the description below. At this point, I want to say this. It's not good science to take a data set and just randomly stab around blindly hoping to find something that's statistically significant. Before you interrogate the data, you start off by defining your question, your hypothesis. You define your null hypothesis. You identify the alpha value that you're going to use, and then you analyze the data. So let's look at what we can do with just one categorical variable like gender. We might ask the question, is there a difference in the number of men and women in the population? Now, we could state that as a hypothesis, which is that there is a difference between the number of men and women in the population. And we could check to see whether or not we think that that is the case. And when we look at our sample data, well, we do in fact see that there's a difference in the proportion of men and women. So should we get excited? Well, no, not yet. Remember, this is just sample data. We could have, by chance, selected a sample that just happened to show a difference. So let's consider the possibility that in actual fact, there is no difference in the number of men and women in the population. And we call that our null hypothesis. And if that were true, how likely would it be? What are the chances? What is the probability that we would see the difference that we have observed, or a greater difference for that matter? And if we can show that that probability is low, then we can have a degree of confidence that the null hypothesis is wrong and we can reject it. But before we calculate this probability, which we're going to call our p-value, we must be clear about how small is small enough. Below what value of p would we reject the null? And we must decide on that cutoff before we calculate the p-value. And we call that cutoff the alpha value. And for the rest of the examples in this video, we're going to use an alpha value of 0.05 or 5%. So we've really got 2 scenarios. We've got the null hypothesis, which is that there's no difference, and the alternative hypothesis, which is that there is a difference. And the next step is to apply a statistical test. And in this case, we do a one sample proportion test, and we generate a p-value. If the p is less than the alpha, then we can reject the null hypothesis and state that the difference that we observe is statistically significant. If we add another categorical variable, in this case, age group, we may have a research question like, does the proportion of males and females differ across these groups? So our hypothesis is that the number of men and women that we observe is dependent on the age category that we look at. In other words, the proportions change or depend on or are dependent on the age category. Now we can collect our sample data, we look at it, and we can see that yes, in fact, the proportions do change across the age groups. In other words, in our sample data, the proportions are dependent on age category. Now, is that due to chance? Well, let's test the idea that the proportions are all the same, or that they are independent of age category. That's our null hypothesis. Now here we can conduct a chi-squared test, and that gives us a p-value, and if the p-value is less than the alpha, we can reject the null hypothesis and state that our observation is statistically significant. If we want to look at just one numeric variable on its own, like height, then we don't have any groups to look for differences between, and we don't have another numeric variable to look for some sort of association or relationship with. So what questions can we ask? Well, we might have some theoretical value that we want to compare our data to. For example, in the case of average height, we might have some historic data. We might wonder if the current population is significantly different from that historic data. So our question might be, is the average height different from a previously established height? Let's imagine that the previously established height was 1.4 meters. We want to know if the average height in our current population is different to that. Our hypothesis is that there is a difference. Again, we collect some sample data. We find that the average height is indeed different from the historic height. Is that statistically significant? Well, if there were no difference, what would the chances be that we observe the difference that we do, or a greater difference? We conduct a t-test, comparing the averages, and if the p-value is less than the alpha, then we can reject the null hypothesis and state that the observed difference is statistically significant. Now let's consider a categoric and a numeric variable. And we may ask the question, is there a difference between the average height of men and women in this case? Our hypothesis is that there is a difference. In our sample, we do observe a difference. Let's assume that there's no difference. We conduct a t-test, which gives us a p-value. If the p is less than the alpha, we reject the null, and we state that the observation is statistically significant. If we had a categorical variable with more than two categories, like age group that's got 3 categories, then instead of doing a t-test, we would do an analysis of variance, or ANOVA. Now let's look at the last combination of variable types in this data set, 2 numeric variables, height and weight. Here we might start with the question, is there a relationship between height and weight? Our hypothesis is that there is a relationship. We collect sample data, we look at it, and voila, we do see some sort of relationship. Is it real? Well, let's assume that it's not. Let's assume that there's no correlation between the 2 variables. And if it weren't real, then what are the chances that we'd see the relationship that we do? And here we conduct a correlation test. Now, a correlation test is going to give us 2 things. Firstly, it's going to give you a correlation coefficient, which tells us something about the nature of the association between the 2 variables. And I'm going to talk about that in just a minute. But of course, it also gives us a p-value. And again, if the p-value is less than the alpha, we can reject the null hypothesis and state that the correlation that we see is statistically significant. And the correlation that we see can be represented by a number that we call the correlation coefficient. So let's talk about that for a second. The correlation coefficient is a number between -1 and 1. And it looks at the relationship between 2 numeric variables. If, as the x variable gets larger, the y variable gets smaller, we say that they are negatively correlated. If they are perfectly negatively correlated, then the correlation coefficient will be -1. If there's no relationship between the 2 variables, then the correlation coefficient will be 0. And if there's a perfectly positive correlation, as x goes up, y goes up, then the correlation coefficient will be 1. And of course, you can have any value in between. And by the way, it doesn't matter which of your variables is on the x and the y axis. The correlation coefficient will be the same. Now, of course, we've only just been able to scratch the surface in terms of what there is to learn about statistical analysis. If you want to learn more, then go to learnmore365.com, and I've got some courses there that you're going to love. And if you'd like to learn about R programming, which is a programming language that gets used for statistical analysis, and it's free, it's very powerful, it's easy to use, it's absolutely fantastic. I have a YouTube channel that focuses specifically on that, so that's R Programming 101. I'll put a link in the description below, go and check it out. Otherwise, please subscribe to this channel. We reject the null, and we state that the observation is statistically significant. If we had a categorical variable.
Okay, so I guess that's about t-tests, chi-square test, no, although hindi naman siya masyado nag-mention about chi-square, but yung use, more of the uses of this t-test and ANOVA test, no, or definitely the chi-square test, no, pareho lang naman siya of principles, and also you can use this using Excel, for example, no? So, I think klaro naman masyado yung presentation. That's why it's statistics made easy. So, do you have any questions or clarifications between differences about categorical data and numerical data, and the different tests, no? Or yung questions or hypotheses? These are very common on social sciences and also in agribusiness. So do you have any questions or clarification? Anyone? Anyone na may pangutana about t-test? So actually, do you know already how to use the t-test in your Excel? Kabalo na mo?
Dili, ma'am.
Okay, I'm going to show you the t-test using Excel. We also have t-test in using what they call that, SPSS and other statistical tools na mga app, no? But then we can also
Your work can feel
Excel, which is also very helpful na siya. Kasi wait lang.
much smoother with Monday.com WorkOS.
Commonly lang ginagamit ng
This
Excel.
So this is a quick video how to do
We already have, Excel, no? We can just use Excel for free kasi yung mga SPSS, SAS, and everything are mahal yan, no? They are paid. So let's watch paano gamitin ang Excel for t-test, no? Paano natin i-insert ang t-test. So let's just watch.
t-test in Excel. A t-test is when you have two conditions and you'd like to compare the differences between the conditions to see if it's significant. So my two conditions was just measuring reaction time to a stimulus in milliseconds. So I have my reaction times for condition A, my reaction times for condition B, and I'd like to see if there's a difference. Now these two means can either come from the same people, so for example this could be reaction times in the morning and this could be reaction times in the afternoon from the same people, so each row represents one subject. Or it could be that I had separate subjects in each condition. So I tested these participants in the morning and a separate set of participants in the afternoon. Now depending on what your design is, depends on what type of t-test you'd use. For the first type, when the means come from the same participants, it will be a related t-test, sometimes called a paired t-test. The way to do this in Excel is to first of all select a clear cell. So here I've got E6 highlighted. Then you hit on the keyboard equals, then write t-test, open brackets. Now you can see here that Excel is prompting me to enter array 1. What this means is it would like you to first select the means from the first condition. So here we have these means, so I just click and drag all of these. Once they are selected, I hit comma, and we'll see that we've moved on. Now Excel is asking you to highlight array 2. So this is just the means from the second condition. So now I highlight the second ones. Now hit comma. Microsoft is now asking me to determine how many tails the test has. So if you predict that there will be a difference between these two conditions and you have a directional hypothesis, i.e. that condition A will be faster than condition B, for example, then this would be a one-tailed test because you predict the direction of the effect. If you're unclear, it's always best to do a two-tailed test. So this is when you predict that although there may be a difference, you're not sure which condition will be different, faster or slower than the other. So in my case it's a one-tailed test, so I just click 1, hit comma again. Now it's asking me for type. Now this is where you distinguish in Excel whether the data comes from the same participants or from different participants. You have to enter a number here from 1 to 3, so 1, 2 or 3, depending on what your design is. So my design is a repeated measures design. Each participant took part in both conditions. This would be type 1. Type 2 is where the means come from different groups. Type 3 is also where they come from different groups. So what's the difference between type 2 and type 3? Well, type 2, if you were to enter a 2 here instead of a 1, you're telling Excel that the means come from different groups and that the variance associated with each group are the same, statistically the same. So you're saying that the two groups, the variance of the two groups have equal variance. If the variance of the two groups is unequal, you would do a type 3. If you're unsure whether there's equal variance between the two groups, you can test for this statistically, perhaps cover this in a different video, but for simplicity, always best to assume that it's unequal variance, because that makes the tests stricter. So you would choose type 3. But for our case, it's a repeated measures design, so we type 1. Now we close off the brackets and hit return. And now Excel has computed a value of 0.01672. What this is your probabilities. This is your p-value. So in psychology we use criteria of p less than 0.05. So our value here is less than 0.05. So that says that the difference between these two conditions is significant at the 0.05 level. So just below it, we'll have a go at the other ones. So again, you just equals t-test, open your parentheses, select array 1, and then array 2. Let's do a one-tailed test again, and now do a independent t-test, so between subjects, but equal variance is assumed. Close brackets, hit return, and here we have a p-value of 0.00468, so it's highly significant also. So this is how to do a t-test in Excel. It's really simple, so have a play around with it and see how you get on.
Okay, so I guess that would be all, no, for t-test. And do you have any questions or clarification regarding how to use t-test?
Mag-Bear Brand Adult Plus.
And again, reviewing how to do it in an Excel. So madali lang siya. So whenever you forgot, you can always go back to YouTube, no, and search for t-test using Excel, or actually sa Excel mismo, no, I can show you. Saan ba yung Excel natin dito? If you're going to use different statistics, you can actually just read. Pwede mo lang basahin kung ano yung set up pa siya. Oh my golly. Yes. Okay. I don't know what happened. So actually, pag i-click lang niyo siya ang function, no, naa siya, what do you call that? Description sa side. Kung paano siya, ano ibig sabihin ng mga different yung formula, no? But for example, let me just fix my Excel, and so maybe I can show you next time. No? And but for this time, we mahukdan pag time, no, pag ako pa ning i-install. So that would be all muna for t-test. So simple lang siya, no, like naabay difference ang age and height between men and women. So you can answer the question using your hypothesis, no, null and alternative hypothesis using t-test ko. So ang t-test mo, i-sure lang nimo siya nga na yung difference. So kasi kung makita na nimo sa data, of course, na yung difference ang height and ang weight sa mga female o male. Kaya lahi-lahi man yun siya, di man siya parehong number. But then, statistically, na-adjud ba? So, in order to measure that one, you need to use the t-test, no? So, ayun, pag solve na nimo sa t-test using sa Excel, yung kanina na ipinakita sa video, just go back to the video. So, kapag less than 0.05 siya, meaning it's significant. Meaning, naagos siya difference based on statistics. So, yun lang, no? You can also, aside from height or weight, we can also say that na-abide, difference ang lalaki, of course, it's common knowledge, no? Between female and male, but not in height and weight, but also in studying behavior, na-aba. So it's maybe there are already study conducted on that, and we can perhaps read, no? But if none, then we can always, do surveys and then analyze the data. So I guess yun lang. So much for that. Do you have any questions or clarification? Anyone? So, klaro ba? Masabtan ba ninyo o wala? So, kasi for me, it's clear. The presentation is clear. And you just have to, go back again. If at first, medyo naglibog pa mo. Pero pag once na ginabalik-balik naman ninyo, syempre, kasing mga t-test, mga statistical, no? Like, I'm already old and I'm already in PhD level. Siguro ginagbalik-balik. So, ang technique lang, ana, para masabtan nato, is to always, listen again and again. No, it's also same with if you want to memorize something or if you want to memorize the scientific name of a particular plant or animal, you just say the word again and again 5 times. Don't shadow sa 5 times, di mo na ma-memorize, then you need some more. So, anak lang siya. So, thank you very much for joining for today's session. And it's we're almost done with our actually ang ginahulat na lang nako is ang inyong mga research proposal. No, so thank you very much for your time. I hope to see you again next week. Any questions or clarification? Yes, John Ray.
Wala po, ma'am. Thank you po.
Yeah, how about the rest? Jessa, Vanessa, Novi, Jacqueline, Sarah. Okay, so by the way, sa itong mga gipang-send ako, actually gipasend ni ma'am April, but hindi ko fully talaga nabasa lahat. So please also take time to read because those information were meant for you naman. And I have to read it later. So again, thank you. Happy Friday, and I know may klase every Saturday. But anyway, happy weekend, and hinahinay lang sa takong kapuyon, ginhawa lang kadali, and balik na punta sa atong
Excuse me, pwede mahabol. Ma'am, sa proposal, good ma'am, ka nang mag-defense niya na.
Yes, muna akong ginahulat. Bahalag dili sa ninyo, like for the title, no? Kasi ang final sa title, kung kinsa inyo ang mapili nga advisor, puhon. So, pag 4th year na ninyo. So, by now, i-pursue sa ng title and let's see kung sa akong mga suggestion, no, while you are presenting. And then, after i-screen na po na niyo. I-screen na po na sa inyong panel. Okay. Okay ra, Van?
Yes, ma'am.
Okay.
So good na, ma'am.
Oo, kasi kailangan ma-present na siya starting December, and this week is the last week of November, diba? So next week supposedly dapat na one group na maka-present per week. And then marami tayong holidays by kasi December. Diba? Hanggang lang siguro tayo, 15 or 18 a week. So one group per week ang presentation.
Ay, ma'am, magpasa sa mix of copies mo para magpa-check, ma'am, kung okay ra ba ni among paper, ma'am.
Yes, pwede if you still have time. No, so I can feedback more before you present. Okay.
Thank you, ma'am.
Okay, thank you everyone.
Than 2 categories,
Thank you,
like age
ma'am.
group that's got 3
Bye-bye.
Oh, thank you, ma'am.
Bye.
categories. Then instead of doing a T
Get up, ano to?